Okay, let's dive into this explainer. July 12th. Now, you might not think much of it, but it's arguably one of the most important dates in the entire history of mathematics. Seriously, here's why. On this exact day, spread across completely different centuries and countries, a handful of brilliant minds were born or died who literally changed the world as we know it. I absolutely love exploring history like it's a giant detective story, so today, let's track down these visionaries one by one and see exactly how they're all connected.
So, let's start with a question. Have you ever wondered why our streaming music sounds so incredibly clear, like crystal clear, without constantly buffering, even when we're stuck on a really slow 4G internet connection?
Well, believe it or not, we owe that flawless audio to a man born way back on July 12, 1875. His name was Ernst Fischer. He basically proved that every single sound wave out there, whether it's a heavy bass line or just your best friend's voice, can be sliced up into these neat little mathematical building blocks called Fourier coefficients. That brilliant foundational concept? It's exactly the math that turns complex, messy audio into this simple digital data that streams so perfectly to our phones right now.
It reveals this totally beautiful truth when you really think about it. Every song you have ever heard, every single one, is secretly made of math.
Okay, so that's 1875. Let's move to 1922 and see how this builds, jumping forward in time to our next incredible mind while still holding on to our golden date, July 12th.
Think about another digital tool we rely on completely every single day. Why does our phone's GPS instantly find the fastest route through, say, hundreds of twisted, chaotic city streets without just getting entirely lost?
Well, we owe that everyday miracle to Ernst Straus, whose brilliantly impactful life came to an end on July 12, 1983. Straus actually worked directly as an assistant to Albert Einstein. Yeah, Einstein. Together they were mapping out the incredibly complex physics of relativity. And it turns out that exact high-level cosmic math is 100% required for our GPS satellites to stay perfectly synchronized with Earth, allowing them to pinpoint our exact locations on a map.
It is just mind-blowing when you zoom out. We literally rely on the physics of space-time just to navigate to a local coffee shop. The math of the cosmos is what guides us to our destination.
One single date. So many wild stories. Let's rewind the clock real quick, dialing it all the way back to 1889.
I want you to think about this ancient mystery for a second. How exactly can we predict the precise time and location of a solar eclipse centuries before it even happens?
Enter Adolphe, born on, you guessed it, July 12, 1889. He was essentially a mathematical detective of antiquity. What he did was translate these incredibly dense, almost impossible to read Greek astronomy texts that had been rescued from ancient ruins. By decoding these lost manuscripts, he actually proved how the ancients calculated planetary movements. He gave us the foundational geometry that we still use today to map out the skies.
It really makes you pause, doesn't it? The secrets of the stars were decoded from ancient ruins.
All right, let's take a massive leap forward now. We're stepping right out of those ancient ruins and straight into the modern digital era. Welcome to 1969.
Now, consider this. How exactly does a computer map millions upon millions of our social media friendships and accurately suggest new connections in literally just a fraction of a second?
That massive, invisible digital web is the life's work of David Cariolaro, a mathematician born on our golden date, July 12, 1969. Now, what's really interesting about this slide is how, at its core, Cariola's work zeroes in on a deceptively simple concept known as graph theory. Basically, this is the mathematics of networks and connections. It's the exact math behind our digital friendships, calculating how individual, scattered points connect to build those massive digital ecosystems that basically run our social platforms today.
So, the very next time you log on, just remember, behind every single friend request is a perfectly drawn mathematical web.
Let's keep this detective story moving, shall we? We are bouncing the timeline back to the year 1942. This brings us to a deeply critical real-world mystery. How do we track a dangerous silent virus and actually stop it from spreading globally across our populations?
Well, we find the blueprint for exactly that in the profound legacy of Jane Wadsworth, whose life tragically ended on July 12, 1997. She achieved something absolutely monumental. By pioneering complex medical statistics and leading massive data tracking surveys, she successfully mapped the patterns of the AIDS epidemic in Britain. Her brilliant work gave doctors the exact data they desperately needed to fight back and save lives.
It really just reveals the deep humanity behind all her work. Numbers aren't just digits on a page. They are the key to saving human lives.
Okay, for our final July 12th profile, let's ask one more question. How do our computers calculate the exact boundaries of really complex digital maps, 3D spaces, or completely chaotic physical borders?
That mind-bendingly complex geometry was cracked by Calogero Vinti, who was born on July 12, 1926. His highly specialized work focused on measuring the perimeters of highly irregular sets, which, honestly, is just a fancy way of saying he figured out how to mathematically measure incredibly chaotic, messy borders. This brilliant breakthrough gave computers the exact calculus they need to generate the 3D models and digital environments that we rely on so heavily today.
It proves, without a doubt, that even the most chaotic shapes have a perfectly measurable boundary.
And that, my friends, brings us to the end of this explainer. When you pull back and really look at this timeline, tying it all together, it's just wild. Fischer, Straus, Rome, Cariolaro, Wadsworth, and Vinti. Different centuries, completely different countries, but all permanently connected by this single golden date of July 12th. But more importantly, they all ask the exact same fundamental question. What is the pattern hiding inside the chaos? And because they ask that, our modern world has GPS, streaming music, social media networks, and life-saving medical data. So, as you go about your day, I want to leave you with this one thought. What invisible mathematical patterns might you discover in your own life today?